Do your welds look like this and you're just not sure how to make them better? Or are they breaking and lacking penetration? Well, if you're having any sort of issues with your MIG welds, you came to the right place because this video is going to be a ultimate MIG welding troubleshooting guide, and we're going to walk through exactly how to find out what your issues could be that's keeping you from getting those results that you want. So let me just kick this off by just saying almost all your problems when it comes to MIG welding boils down to 3 categories. So for example, let's say you have a machine that's just not set up right. There is no setting or technique that's going to be able to get you those results that you want. And the opposite is true. Let's say you have the most elite setup, the best machine, best gear, everything, but your technique and settings aren't right, you still won't be able to get those results that you want. Now, if you notice, I lump settings and technique together because those 2 things just go hand in hand. They directly affect each other, and I'll be going to that a little bit later, but those 2 things are very close connected. But each one of these things kind of has their own issues too, so we're going to be going over all of that later as well. So with all that being said, making sure all 3 of these categories are in check is absolutely critical to be able to create the weld you want. So what I want to do is walk through each one of these categories and point out certain things that could be tripping you up, and just make sure to walk along through with me, because even just a part, just a very tiny part of one of these categories is out of whack, then that could be the one thing that's fighting you. So category number 1 here is machine setup problems. Some of these things are very overlooked and cause a lot of headache, but are super simple to fix, and they take like 5 minutes to double check. So the first one here is wire feeding issues. So feeding issues are super annoying, and if you have feeding issues, you'll notice when you're welding, the arc will like kind of cut in and out, and it won't be consistent wire feeding out. And that is usually caused by not having the right tension on the spool of wire in your machine, not having the right size drive roller groove, or the drive roller tension is not set right, or having a super old or damaged liner, or having a damaged contact tip. So let's check each one of these things off one at a time. First, check your contact tip and make sure that's in good condition, and look over your lead to see if it's damaged at all. And if the liner is super old or damaged, just replace it. It just gives you a peace of mind. That's one less thing you don't have to worry about. The next thing to check is to make sure you have your drive roller flipped around the right way, and make sure you pick the right size groove on your drive roller that matches your wire size you're using. And make sure your drive roller tension is not too loose or too tight. A quick little trick to set this is start loose with your tension, and then hold your gun up to a piece of wood, and then press down the trigger and start feeding the wire out. And then keep holding the trigger down on your MIG gun to keep feeding it out, and then slowly increase the tension on your drive roller until you can have this continuous feed out your gun while hitting this piece of wood and feeding smoothly. But you don't want to over tighten this though, because that's what causes bird nesting inside the machine. The next thing to double check is your spool tension. So for finding the right tension for this, it should be just enough so it doesn't coast back and forth freely when you trigger the gun on and off. Now another setup problem is gas issues. Make sure you have around 20 CFH of flow at the regulator for welding indoors with no wind. And make sure your nozzle doesn't have a ton of buildup like you can see here, which suffocates your gas flow. Also, make sure to double check the little gas diffuser at the end of your gun, because sometimes these little holes right here get plugged up with spatter. And also make sure that the metal you're welding together is clean and raw, and it doesn't have any sort of paint or oils or any other coatings on the material. Another key thing that is sometimes overlooked is making sure you have a good ground connection on bare metal that also isn't painted or has any coatings on it. So if you want more detail about how to set up your MIG welder properly, I have a video going over that whole process right here. And I also create a free MIG welder setup guide that takes you through step by step of the process. So if you want to take advantage of that, check out the link in the description below. So that brings me into category number 2, which is settings issues. Now for finding the right setting for MIG welding in any scenario that you're in, there's 2 goals that you need to hit. And that's finding the right wire speed to voltage ratio and finding the right overall heat to get that good penetration. So those are 2 separate goals, but they do go hand in hand when finding the right setting. Now, like I said earlier, technique also plays a huge role in finding the right setting too, but we're going to be going over that in the next category. So for finding settings, your machine usually has some sort of chart on the inside of the machine like this, and it has like your wire speed and your voltage, what it should be set at for each material thickness. So like I was saying before, the 2 goals you need to hit is find the right wire speed to voltage ratio and finding the right overall heat for that material thickness that you're working with to get that good penetration. So this chart kind of does that already, but the chart in your welder is just a starting point, and I don't recommend just setting your machine to wherever the chart has recommended for that material thickness you're working with and just letting it go and just using that setting for any scenario you're welding in. If that works for you, then great, keep doing it, but I have been really steered wrong by this back when I was first learning how to MIG weld. So following the recommended settings that your machine has is going to be okay for maybe in the flat position on like a fillet weld, but once you do anything outside of that, like vertical, overhead, outside corners, lap joints, butt joints, whatever, anything outside of that, everything changes. Your technique changes, your setting changes, everything changes. So you have to get familiar with what each setting does, whether it be wire speed or voltage, how to adjust it up or down, what happens when you adjust it up or down, and just getting comfortable with adjusting your settings and not solely relying on this chart is so key. So problem number one with settings is having too much wire speed. When you have too much wire speed, you'll hear more of a buzzing sound. And when welding, you'll notice the arc might be popping more, and sometimes the wire bounces off the puddle. And you'll notice the puddle just piles up and it just doesn't sink into that material. And then the finished bead might look more bulged out and the edges won't be fused that good. And then problem number two is having too much voltage. You'll notice the arc might have more of a hissing sound and the wire won't make it to the puddle. It'll just ball up and then drop into it. And you can hear it too. And the puddle will be just more watery and just out of control. And the finished bead might be like underfilled and undercut. So having the right ratio between wire speed and voltage and having that good balance between the two is really key to have it weld right. Now, like I said before, finding the right ratio for your wire speed to voltage is just one part of finding the right setting for whatever scenario you're welding in. So you also need the right amount of heat to get good penetration on whatever material thickness you're welding. So let me explain this for a second. So this is, we'll just pretend this is the range of what your machine can actually weld. This is like the top side is like your heavy stuff, like the maximum your machine can weld, and the bottom side is like the thinner stuff. This is like as low as your machine can weld. So let's say, for example, the top side, the maximum that your machine can weld is, let's say, 1/2 inch plate. And the bottom side, this is like the thinnest it can weld, is like, let's say 20 gauge. So for example, let's say you're welding 1/4 inch steel and 1/4 inch in this range. Let's say we'll put 1/4 inch right around here somewhere. Now, if you follow that chart in your welder, it's going to tell you, all right, for 1/4 inch steel, you need to have your wire speed and voltage set to this. So let's say your wire speed to voltage, let's see, wire speed and voltage. So that's just set, we'll just say those are set to X and Y. So that is what you have your machine set at for 1/4 inch steel. But the kicker is you want to weld in the vertical position. Now everything changes now because that setting is going to be way too hot and way out of control because it's just too much output for you to be able to handle in the vertical position. It's just going to want to clump up in the center of the weld. It's just going to be falling down. You won't be able to control it. So what you need to do is you need to turn down the overall output of your settings. So that's turning down your wire speed and turning down your voltage. So you're turning down X and Y here lower. So now instead of it being here, now you're down here with your wire speed and voltage setting. So now your overall output is lower, but you still have that ratio of your wire speed and your voltage the same. So you might need to just fine tune it from there. But now your overall output is lower now, so you should be able to control your puddle way better now. So when you're first starting out and you're a beginner, you might have to rely on that machine chart in your welder to kind of give you just some sort of number to start at and then adjust it from there. But the more experience you get and the more experience you have with adjusting your dials and just remembering what your dials are at for certain material thicknesses, then you kind of have a better idea of what you should have your dials set to for different welding scenarios. So the way I adjust my settings for whatever welding scenario I'm in, this is how I do it. I always start hot with my settings, and then I slowly back it down until I can control that puddle to whatever scenario I'm working with. So this is what it looks like. I always start with a number that I know is going to be hotter than what I need. You don't go crazy with this. You don't gotta just crank it all the way up and then turn it down. Just turn it hotter than what you need. So let's say the perfect setting is here somewhere. So I don't know what I should have my dials set to get to that perfect setting. So I just turn them up to around here somewhere. So I always start hot, and then my wire speed to voltage ratio, I try to get that pretty close. And so wire speed, voltage, I try to get that pretty close. I'm not dialing it now because I know I'm going to be way too hot for what I want to be at. So I get that pretty close, and then I notice that I'm running way too hot, so I'll turn both of them down, turn both dials down, so you keep that ratio the same, just a lower output of heat. So I'll turn these down, and that'll get me to around here somewhere. It might be still a little bit hot yet, but it's getting closer than when I was before. So bring that, I'll turn them both down. I'll see how it runs. If I can still kind of manage the puddle, I might stick with it, but if I want to control the puddle even more yet for certain scenarios, I might turn them down even more yet, and still keeping the wire speed to voltage ratio the same. So I'm turning both those dials down even further now to bring me down to where I want to be at. And once I get there, and now I can finally control the puddle, and it's getting pretty close to where I want to be. Now is when I fine tune that wire speed to voltage ratio and get that really dialed for this heat output. And once I fine tune those two dials, the voltage and the wire speed, then is when I have the proper setting for that scenario that I'm in. So settings is all about finding the right overall heat output and the right wire speed to voltage ratio. But like I said earlier in the video, your technique adds a whole other variable to finding these settings. So this is a very overlooked thing that I see beginners make, and trying to find that right setting for their scenario. So I made this mistake myself when I was first learning how to MIG weld, and I just spent so much time just chasing settings, and like if I just had those dials just turned just right, I could get that perfect setting and get that perfect slick weld then. But what I didn't realize was that there was this whole other side of the coin that has to be on point to get the results that I wanted. So let me walk you through some of these technique mistakes that I made and some things to look out for. So the first one here is too long of an arc length. Now I can get technical about what actually happens, but basically the further your gun is from the puddle, it will start to run colder and almost seem like someone turned down the voltage. So this is when things could get dicey. If you're not consistently close to the weld with the tip of your gun, you might think there's something wrong with your machine, or you might start messing with the voltage dial thinking it needs to be hotter. However, you could be adjusting the wrong thing, and it could make things worse. When in reality, all you need to do is just move a little closer to the weld and your problem is solved. So the next potential problem could be travel speed. So in general, if you travel too fast, the puddle doesn't have enough time to get established, and the bead will look like really narrow, cold, and just really inconsistent. And on the other hand, if you travel too slow, the puddle gets big and built up, and it'll be just hard to control. So if your travel speed is not right, and you just start messing with the voltage and wire speed dials thinking that could fix your issue, when again, you could be adjusting the wrong thing here, and it could make things worse. So with travel speed, you want to be traveling slow enough to let the puddle get established, but also quick enough so the puddle doesn't get too big and out of control. So there's a happy medium there, and this speed is solely dictated by the puddle. So if your joint needs to be filled out more, just travel a little bit slower and let that puddle fill in the joint. And if the puddle's getting big and out of hand, then you travel a little bit faster. It's literally that simple. Also with this, I recommend having a pulling angle on your gun so you can see the puddle clearly and see exactly what's happening, and then you'll be able to course correct your technique or travel speed way more effectively. If you have a push angle with your gun, the nozzle kind of blocks your line of sight with your puddle, and you can't see if you need to be traveling faster or slower or adjusting your technique at all. Now, in some situations, you need to have more of a push angle to kind of get in tighter spots, or if you're in a certain position and you need to adjust your angle to weld better, for example, like the vertical uphill position, you technically have a pushing angle, but in general, just make sure you have your gun angle right so you can see the puddle. Now, when it comes to welding in any other position other than the flat position, you'll most likely need some sort of movement with your gun to help fight gravity and make your weld look good. So with the vertical uphill position again, for example, I like to use the stacking triangles motion to help manage the puddle better. And with different positions like this, each position gets affected by gravity differently, so the motion you do changes depending on what position you're in and what joint type you're working with. And again, watching the puddle is huge here, because depending on what it's doing from gravity affecting it, that determines what movement you do. Now, if you need more help with welding in certain positions, come check out the channel. I have some other videos that go into more detail on each position. So the last thing with technique here I want to mention is just make sure your arms are propped or brace yourself somehow to get yourself in the most comfortable position possible. This is a huge thing I see beginners overlook, and this helps you out so much to get that good consistent weld. The more comfortable you are, the better welds you can put down. So with all this being said, there is a balance between having the right technique and having the right settings to get you the good weld and the slick weld that you want. And if you're a beginner, you're not gonna nail this right out of the gate. It's gonna take a ton of practice to get good technique down and get familiar with adjusting your voltage and wire speed dials. But just as long as you are aware of this balance, and that is a huge step, because when I was first a beginner, I had no idea. I thought it was just either settings or technique. I didn't know they intersected. So just being aware of the balance is huge, because then it's just a matter of just putting the practice in to get better at it. Now, like I said in the beginning of the video, almost all your problems fall into these three categories. So since you're working with technology, there are other issues that could arise as far as like machine problems and internal machine issues. So if you have like a really old machine, like this was Adam and Eve's first welder, and things are starting to fall apart or just not really work great anymore, or if you have like a really cheap like Chinese brand, no-namer, off-brand welder, like when you're dealing with different machines like that, you just have more of a chance to have problems with the machine itself. And if you're going through these categories like I went over before and you're just having issues and you just can't figure out why, maybe it could be a machine issue. So I always recommend just staying with a good name brand welding machine that's been around for a while and they have a good reputation, and you don't have to be brand new. You can be like a used one off a marketplace. Like you don't have to completely ball out on this brand new machine. Like this MIG machine that I have here, I just got for like a really good deal off a marketplace. It's a Miller, solid welder. I mean, it's old, but it works great, has no issues with it. And yeah, it might cost a little bit extra to buy the name brand machines versus like the Chinese no-name off-brand machines, but the name brand machines are solid. They last a long time. They're just really well-built machines, and it's definitely worth the extra money that you have to spend. Now, I don't know if you could tell, but I'm a Miller fan, and I just love Millers. I've just grown up on Millers. I've learned on Millers, and I've always had great success. And I've also used Lincolns too. They're pretty good too, but would just recommend you just do your research before you buy a machine. Make sure you buy a solid welder that's going to give you consistent, good results and be a solid machine for a long time. So my point in saying all of this is that you don't want machine issues or weird machine quirks on top of trying to learn how to weld. It's just like another unnecessary obstacle that you have to be challenged with. It just makes learning way harder than it needs to be. Because now you don't know if you're fighting the machine or you're fighting yourself, your technique or your settings. There's just adds a whole nother potential issue. It's just not worth it. And once you buy that reliable, really solid machine, you'll have a great machine for a long time. You'll learn way faster and way less headache. So if you just got a MIG welding machine and you're not quite sure how to set it up, or if you just want a refresher just to make sure that you have your machine set up correctly and that's not something else you're fighting, I have a complete setup guide in the description down below. I'll leave a link there for you. Or if you want a video to kind of help walk you through the whole process, you can click this guy right here.